Assalamualaikum and a very good day. My name is Muhammad Arif Iskandar. I am a student for Mechanical Engineering, currently studying Fluid Mechanics 1, and this is a lab presentation for Lab 2 under Fluid Dynamics. So for introduction, this whole lab will be about Bernoulli's principle, and this principle states that as the speed of a fluid increases, the pressure within the fluid will decrease. So this statement right here will follow the following equation right here. Next, we will also be looking into the Venturi effect that states the reduction in fluid pressure as a result of the fluid flowing through a constricted section of a pipe, and this statement follows the following equation right here. So that's for introduction. Next, we will see the objectives, why we are doing this actual experiment. First, we want to experimentally verify the accuracy of Bernoulli's principle. So that's the first objective we are doing this experiment. And next, we want to also investigate the relationship between the speed of a given fluid and the resulting pressure of that fluid. So this is under the Bernoulli's principle stated just now. And finally, we know in theory, a smaller diameter in area of a pipe results in a higher fluid speed and a lower fluid pressure, and this one is under Venturi effect that follows this equation right here. Q is equals to VA. So that's for the objective. Next, we move on with the actual experiment that we are going to run for this lab. As you can see the figure on the top right here, this is the apparatus setup for this experiment, where we have a water tank filled with water, of course, connected to a Venturi tube right here. We're using a water pipe around here that has a valve to control the water flow, and then at the end of the Venturi tube we have a clip to control the water flow into the sink that we have at the end of the water flow. So this section right here have the following sketch, as you can see here. To see it more closely, how we have tube A, tube B, and tube C. Next, for the actual steps, first we are going to prepare the apparatus as shown in the figure right here, and then what we are going to do is to open the water pipe valve around here, which is here, to allow water from the water tank to flow into the Venturi tube until the water level inside tube A, B, and C reach a decent height. What I mean here is when the water flow, water will rise in the tubes. So we will want to wait until the water reaches around half the actual height of the 3 tubes. So when that happens, what we are going to do is to release the clip right here to allow water flow into the sink. So after we've done that, we are going to adjust the water pipe valve and also the clip here until the water level in each tube reaches a stable state. And when that happens, we are going to observe and record the height of the water level in each tube. So that's for the methodology and apparatus setup. Next, for results and discussion, as you can see in this figure here, this is the results of the experiment that we've done just now. In point 1, where we have a larger diameter, a larger area, we will have a larger height level in tube A, as you can see in point 1. And then we have in point 2, we have a way smaller diameter or smaller area, which results in a smaller height level in tube B. And finally, in point 3, we have a large diameter, which is closely with the diameter in point 1. And we will have a height level in tube C, which is still lower compared to tube B. So what this means is that the area of the diameter increase, the velocity of water will decrease, and thus the pressure will increase. So this follows the following equation, Q equals to VA. So in conclusion, as expected, as we stated in the objectives, as the area increases, the speed of the fluid will decrease and the pressure of the fluid will increase. So all in all, to conclude, pressure is inversely proportional to the velocity in a given fluid, and thus Bernoulli's principle is verified. So that is all for Lab 2 Fluid Dynamics from me. Thank you.